Section 7.8, solving problems using quadratic models. So now that we've learned all the different strategies to solve quadratic equations, whether that's factoring, graphing, or the quadratic formula, now we're going to use problems. So we're going to have to take word problems and change them into mathematical language, okay? There's lots of great examples in your textbook, so I'll get you to read those over or look at similar examples, but I'll just read this with you. A function, a graph, or a table of values can represent a relation. So they could give you a function, y equals x squared plus 7. They could give you a picture, or they could give you a table of values. Use the form that is most helpful for the context of the problem. Depending on the information that is given in a problem, you can use the quadratic function in vertex form or in standard form to model the situation. So vertex form is y equals bracket x minus p squared plus q. Or standard form, that's when y equals ax squared plus bx plus c. A problem may only have one admissible solution, even though the quadratic equation that is used to represent the problem has two solutions. When you solve an equation, verify that your solutions make sense. So if it's asking you for the number of boats and one of your solutions is -4, that doesn't make sense because there's no such thing as -4 boats. Or if you're talking about people and it says one of the solutions is 3/4, doesn't make sense, okay? So you use it to model the problem, but the solution, you still have to use common sense to make sure it makes sense. Okay, you have a couple questions to try in this section.